Welcome back. Let's do question 3.1. For which values of x will this series exist? Right. So what are you finding here? We're finding sum to infinity, right? And then to have sum to infinity, our series should be converging. When the series is converging, it means that our r should be less than 1 but greater than -1. Okay, that's the condition for a converging series. And then for this converging series, we can find what? The sum to infinity. Right. And then what is our r? If you check here, our r is actually 4x minus 1. Okay. If you want, you can find your term 1, term 2, term 3. Right. Term 1, where there's k, you put 1. So it means it's 4x minus 1. Then term 2, where there's k, you put 2. It's 4x minus 1 squared. And then where there's k, you put 3. Third term is 4x minus 1 cubed. You see that? So if you divide term 2 divided by term 1 or term 3 divided by term 2, we get our r. So it means for this series to exist, our r, which is 4x minus 1, should be greater than -1 but less than 1. So where there's r here, we put 4x minus 1, then less than 1, greater than -1. Then we solve this inequality. Okay, so what you do here, we add 1 on both sides. So it means we add 1 everywhere actually, right? So it means here is plus 1, plus 1, plus 1, right? And then what we get, -1 plus 1 is 0, less than 4x minus 1 plus 1, we remain with 4x. And then less than 1 plus 1 is 2, right? And then what we do after that, divide everything by 4, divide by 4, divide by 4, divide by 4. We want to get x. And then what we get, 0 divided by 4 is 0, less than 4x divided by 4 is x, less than 1 over 2, because 2 over 4 is 1 over 2. So it means for this series to converge, our x should be between 0 and 1 over 2. Okay, x should be greater than 0 but less than 1 over 2. But if you check, our r cannot be 0. So meaning that our x cannot be 1 over 4. If x is 1 over 4, what will happen? We have 4 times 1 over 4, then minus 1, isn't it? Which is 1 minus 1, and then which is 0. So our r cannot be 0. So therefore, there's a condition here. We can say that x should not be equal to 1 over 4. 3.2. The figure below shows a pattern of 5 circles touching externally, like shown on the diagram there, whose centers lie on a straight line of length L. The radii of these circles form a geometric pattern where the radius of the smallest circle is 3 and that of the fifth largest circle is 48. Determine the common ratio of the geometric pattern formed by the radii of the circles. So actually here we have T1 and T5. You see that? Okay. So for the radii, so it means T1 is equal to 3, and then this is equal to A. Remember, T5 is equal to 48. Remember, T5 is A times R to the power 5 minus 1, which is 4. So using our A here, we can substitute A with 3, and then remember 48 is equal to 3 times R to the power 4. Divide by 3 on both sides of the equation. 16 is equal to R to the power 4. Then we can find the fourth root here, or we know that this is 2 to the power 4. 16 is 2 to the power 4 is equal to R to the power 4. Therefore, R is equal to 2. And then it cannot be -2 because we're talking about radii here. Okay, so the terms are always positive. So R should be 2 there. Okay, so determine the common ratio. We've answered the question. So R is equal to 2. Determine the value of L. The value of L, what are we doing here? It's diameter plus diameter plus diameter plus diameter plus diameter of these 5 terms. So now we can use the diameters, or we can use the radii and then the answer we get, we multiply by 2. Okay, let's do the radii one first. So our radii is 3, our r is 2, so it's going to be 6, then 12, then 24, then 48. So what you can do, you can just add this 3 plus 6 plus 12 plus 24 plus 48. You will get what? You will get your 93. But you can use the formula Sn is equal to A Rn minus 1 over R minus 1. So sum of the 5 terms here, our A is 3, and then ratio is 2 to the power 5 minus 1 over 2 minus 1. Then we get 93. But this is the sum of the radii. So for the length of L, we're adding diameters. So it's going to be 93 times 2, which is 186 units. Okay. If you want to use the diameters, it's going to be 6 here, 12, 24, 48, 96. You see that? Because diameter is 2 times radius. So you can add these 5 terms or use the formula S5. Okay, we're using the same formula here. So A is 6, and then R is still 2, 2 to the power 5 minus 1 over 2 minus 1, which is equal to 186 units. Okay, that's how we can do that. Then 3.3.3, the pattern is extended by 5 more circles to 10. Calculate in terms of pi the total area of the 10 circles of the new pattern. Right, remember the area of a circle is equal to pi r squared. Okay, so it means for the first circle we have pi 3 squared. Then the second circle we have pi 6 squared. And then the third one we have pi 12 squared. It goes on up to the 10th one. Okay, let's check what we have here. We have 9 pi, and then 36 pi, and then 144 pi. It goes on like that. It's a new series. Okay, calculate in terms of pi the total area. So it means here we're adding this. We're adding, so it's a series. And then if you check here, if you say 36 pi divided by 9 pi, you get 4. 36 pi divided by 9 pi, you get 4. Even 144 pi divided by 36 pi, you get 4. So it means r is equal to 4, right? So now we can use our formula Sn. Now we have this formula which we used. So it's now sum of the 10 terms is equal to, our first term is 9 pi, and then r, which is 4, n is 10 minus 1 over 4 minus 1. Right, 4 minus 1 is 3, so, and then 9 pi divided by 3 is 3 pi, and then this in the bracket, 4 to the power 10 minus 1 will give you 1,048,575. Right, and then if you multiply this and this, they say it in terms of pi, so we just say 3 times this, our pi remains as it is. So it's going to be 3,145,725 pi. That's the answer. Okay, and then square units.